Let's go to page 375 and start with number 1. Okay, so you have p of x is equal to x to the 3 minus 2x squared minus 5x minus 7. And so you have c equal to 4. So that means you want to substitute this into here. So actually, it's more like x equal to 4. Okay, so now normally you will just substitute this and just work it out. Okay, but the easy way to do it is synthetic division. So realize that the evaluation and the remainders from the substitution from the synthetic division are the same. So you're going to get 1, negative 2, negative 5, negative 7. Okay, so just put this number over here. Now you don't have to take the opposite because these are equal. Okay, okay, so you drop the number, multiply, you add, multiply, you add, multiply, you add. Okay, so the remainder, the answer would be 5. Okay, so that's how you do it, very quick. Okay, so this is the shortcut. Now, if you don't know the shortcut, you have to, the normal way you would do it is you substitute. So you're going to get 4 to the 3 power minus 2 times 4 squared minus 5 times 4 minus 7. So you got 64 minus 32 minus 20 minus 7. Okay, and so you end up with 5. Okay, so you should get the same thing. Okay, but again, synthetic division is much quicker. Okay, okay, number 3. You have p of x is equal to 2 minus 5x plus 3x squared plus 2x3. Okay, and but they kind of use a c, but it's supposed to be x, so you have x equal to negative 3. Okay, okay, now you have to be careful. You have to put this in correct order, so it'd be 2. So it'd be 2, 3, negative 5, 2. Okay, so put negative 3 over here, so drop, multiply, you add, multiply, you add, multiply, you add. Okay, and again, so your answer would be just equal to negative 10. So again, this is much quicker than doing that. And usually when you do this, most of the time you don't need a calculator. Okay. Okay, number 5, you have p of x equal to 4x to the 3 minus 4x squared plus 5x plus 1, and x equal to 3 over 2. Okay, so you can use your synthetic division. So you got 4, negative 4, 5, 1. So 3 over 2. So drop the number, so multiply, you get 6. You add, multiply, you add, multiply, and then you add. Okay, so answer would be 13. Okay, again, you can check your answer by substituting and work it out. Okay, okay, number 7. P of x equal to 2x to the 4 minus x to the 3 plus x minus 2, and you want x equal to negative 3 over 2. Okay, so again, you get 2, negative 1. Now you have to be careful now. There's no x squared, so you have to put 0, okay, and 1, negative 2. So when there's a missing term, you have to put a 0. Okay, so drop, multiply, you add, multiply, you add, multiply, you add, multiply, and when you add, you get 10. Okay, so again, the remainder would be same as the evaluation. So this is called the remainder theorem. Okay. Okay, so remember that they are interchangeable, right? So the remainder, so in synthetic division, the remainder you get from synthetic division and the evaluation are interchangeable. Okay, as you can see from this over here, they are interchangeable. Okay, so now, instead of using the evaluation, we use synthetic division. Okay, so now on the next part, we're going to do the opposite. Okay, so number 9, you have x plus 1. Okay, and you have p of x is equal to x to the 7 minus x to the 5 plus x to the 3 minus x. Okay? Okay, so you want to find if this is a factor of these. Now, if this is a factor of these, that means when you divide, you will divide exactly. So if it's a factor, that means the remainder will equal to 0. Okay? And so what you want to do, you want to substitute to see what this is equal to. Okay? So over here, when you set this equal to 0, x equal to -1, right? So p of -1, again, you want to set this equal to 0 and you solve for x. So over here, x equal to -1. So when x equal to -1, you're going to get -1 to the 7th minus -1 to the 5 plus -1 to the 3 minus -1. And the reason you want to do this because this is the 7th power. So if you use a standard deviation, it's going to be very long. So in this case, it's quicker if you do the evaluation. Okay? So p of -1 is equal to, so -1 to the 7th power is -1, -1 to the 5th power is -1, and times my negative it becomes +1, and this would be -1, and this becomes +1. So p of -1 equal to 0. Okay? So remember, evaluation and remainder are interchangeable, right? So in this case, evaluation equal to 0, that means remainder equal to 0. If the remainder equal to 0, that means this can divide this exactly, and that means this is a factor. So the answer is yes. Okay? So yes, this is a factor of that, because when you divide, you're going to get remainder equal to 0. Okay? Again, remember, remainder and evaluation are interchangeable, right? So when the exponent is really high, okay, when this is really high, you want to use a substitution like this, okay? And if this is if it's not high power, it's faster if you use standard deviation. Okay, number 11, you have s plus 1, you got p of s equal to s to the 6 minus x to the 5 minus x plus 1, okay? Okay, so again, from here, you're going to get s equal to -1. So you try to look for, again, you set this equal to 0 and you solve, right? So when s equal to -1, it gives you 0. Okay, so substitute, so -1 to the 6th power minus -1 to the 5th power minus -1. So again, whatever you substitute, put in parentheses. So this would become +1. This would become -1 times -1 become +1. And this one +1, +1. So p of -1 will equal to 4. That means when you divide this by this, you're going to get remainder of 4. So it doesn't divide exactly, so this is not a factor of that. So answer is no. Okay. So again, so when it equal to 0 means that when you divide, the remainder is 0. So divide exactly. So this is a factor. This one you have remainder, so does not divide exactly. So this is not a factor of that. Okay, so you got x minus square root of 3, and you got p of x is equal to x to the 3 minus 2x squared minus 3x plus 6. So again, when you set this equal to 0, you solve, you're going to get x equal to square root of 3. So you're looking for p of square root of 3. Right? Again, you can check, right? If you put over here, you're going to get 0. Okay, so you got square root of 3 cubed minus 2 times square root of 3 squared minus 3 times square root of 3 plus 6. So whatever you substitute, put in parentheses. Okay, now there are 3 of them, so 2 of this is going to make an integer 3, and you're going to get left over, right? So again, there are 3 of the square root of 3. Okay, so 2 of the radical can make an integer. This one is going to give you a 3 times -2 will give you -6. Okay, and so this cancel out, so this is equal to 0. So this is yes. Yeah, so this is a yes. Okay, number 15. Okay, you got z minus I. So you got p of z equal to z to the 7 plus z to the 6 plus z to the 5 plus z to the 3 plus z squared plus z plus 1. Okay, so you can, when you set this equal to 0 and you solve, okay, you're going to get I. So in this case, z equal to I. Okay, when you solve, set equal to 0 when you solve. So you're going to look for p of I. So just substitute. So p of I to the 7th power, I to the 6th power, I to the 5th power, I to the 3 power, plus I to the 2 power, plus I plus 1. Okay. So now you can go off to the side. So remember, I to the 7, you can go in the cycle of 4, right? So this is equal to I to the 3, and this is equal to negative I. Okay, so you got to know how to evaluate i's. So it becomes negative I, and I to the 6 equal to I to the 2 equal to negative 1. Okay, I to the 5 equal to I, right? You go backward by 4, cycle 4. So it'd be plus I to the 3 is negative I to the 2 is equal to negative 1, and I is just I. Okay, okay, so let's see. So this one and this one cancel out. This one and this one cancel out. Okay, and let's see. Okay, we're missing z to the 4. Okay, so plus z to the 4. Z to the 4 is 1. Okay, so 7, 6. Okay, this is a 4, so we're missing the I5. So I5 is I. So this is a 5, and this is the 1. Okay, there we go. So this is a 7, 6, 5, 4, 3, 2, 1, 0. Okay. Okay, so this and this cancel out. This and this cancel out. So 18 cancel out. So P of I equal to 0. Okay, so in this case, this is yes. Okay, so just be careful when you copy. Like this one over here, I missed the z to the 4. Okay, so put in here. Okay, let's go to the next one. Okay, a root of the equation is given, and you're going to solve the equation. So you got x to the 3 plus 3x squared minus 3x minus 9 equal to 0. So you're going to have one of the root equal to negative 3. Okay, so if the one of root is given, you can go and divide. So you're going to get 1, 3, negative 9. Okay. So this came from x plus 3 equal to 0. Okay, so this is one of the part. So basically, this you can factor this out of here. Okay, but instead of doing all that, you can just go and do this. Is much quicker. So negative 3, right? So whatever root you have, put it here. You can divide. So drop, multiply, you add, multiply, you add, multiply, you add. Again, because this is a root, so you always have to come equal to 0. Okay, so this divided by that will give you x squared minus 3 equal to 0, right? So x squared, and this is the x term, okay? So from here you can go and solve. So x squared equal to 3, right? Plus 3 on each side. And take the square root, so x equal to plus or minus square root of 3. Okay. So your answer would be negative 3 plus or minus square root of 3. So those are your 3 answers. Again, this is a cube, so you're going to get 3 answers. Okay, next one. Okay, you got t to the 3 minus 11t plus 20 equal to 0. So one of the root equal to negative 4. Okay, so you can divide. Now you have to be careful. There is no square term, so you have to put a 0. Okay, so this is a t to the 3, t to the 2, t to the 1, and no t. Okay, so divide by negative 4. Okay, so you drop the number, use your finger, so multiply, you add, multiply, you add, multiply, you add. Again, always have to equal to 0 because this is a root. If this is a root, that means this came from the factor, we divide exactly, so it will always equal to 0. Okay, so again, this divided by this factor over here will give you x squared or t. It's get to use to the x. Okay, so this is, so you get t squared minus 4t plus 5 equal to 0. Okay, so this is called a depressed equation. And so from here you can go and either do the factoring, or you can try to, I don't think this is factorable. So let's go and use quadratic formula. So a equal to 1, b equal to -4, c equal to 5. So t equal to negative b plus or minus square root of b squared minus 4ac over 2a. Okay, so you can make sure you know your quadratic formula, right? That your x equal to negative b plus or minus square root of b squared minus 4ac over 2a. So make sure you know your quadratic formula. You're going to use it a lot, so make sure you know that. Okay, so so you go and work it out. So this would be square root of 16 minus 20 over 2. So t equal to 4 plus or minus square root of -4 over 2. Okay, and this one, so t equal to 4 plus or minus. Now the square root of 4 becomes 2, and square root of negative is I. Okay, so this becomes this. Okay, and in dividing by 2, so t equal to 2 plus or minus I, right? Dividing by 2. So make sure that you divide all 3 parts by 2. Okay, and so the 3 roots are, the one is giving is -4, and the other 2 that you solve is 2 plus or minus I. Okay. Okay. Now let's go to next one. Okay, it says find a polynomial equation with an integral coefficient that has a giving number as a roots. So you got, so the three roots are giving. Okay, so you're looking for equation. So you have to know where this came from. This came from x minus 1. This came from x minus 2. This answer came from x plus 3 equal to 0. Okay, so again, this came from this. This came from this. This came from this. Okay, again, if you set each one equal to 0, then you get that, right? Again, set this equal to 0, you get the answer. Set this equal to 0, you get that. Set this equal to 0, you get that. So right now we're just going backward. Okay, so next part is you just go and multiply. Okay, so there are 3 factors, so you can only multiply 2 at a time. Let's go and multiply the last 2 first, because I'm so used to the single one in the front. Okay, so you're going to get x minus 1, leave this alone, so multiply these. Okay, now when you multiply, remember that x times, use your FOIL method. So remember the middle term comes from adding, right? So remember this is just like when you're doing your master product. So when you add, okay, you're going to get plus 1, and multiply, you're going to get that, right? Or you can use your FOIL method to FOIL it out. Okay, then after that, then you can go and distribute. Okay, so distribute, so it be x to the 3 plus x squared minus 6x. So done with it. This one, so you go to the next one, so it be minus x squared minus x plus 6 equal to 0. Now let's go and combine the like terms. So it'll be x to the 3 and the square term. The square term cancel out, and then this one here and this one here, minus 7x plus 6 equal to 0, and that would be the answer. Okay. Okay, next one. Okay, the 3 roots are 0, negative, or 4 roots. So 0, -1, 2, and -3. So this came from x. This is like, I can think of it as a x minus 0. Okay, so this is going to be just equal to x. So again, this came from this, so it'd be, and you don't write minus 0, right? So basically this is just means x. Okay, and this one came from x plus 1. This one came from x minus 2. This one came from x plus 3. Okay, so again, this just going to, everything just opposite. Right? Again, if you set this equal to 0, you get that. Set this equal to 0, you solve, you get that. Set equal to 0, you solve, you get that. Set equal to 0, and solve, you get that. Okay. So now you're going to multiply all this together. Okay. Again, remember, you only can multiply 2 factors at a time, right? So what I'm going to do is, I'm going to multiply this 2 and multiply this 2. So this 2, I will get x squared plus x. Okay. And this one over here, I'm going to get x squared. And this one, again, if I add, okay, I get a middle, multiply, I get the last term. Okay. Again, this just reverse of the master product. Okay, my next step is I'm going to distribute. Okay, use your FOIL method. Use the distributive property. So multiply, I get x to the 4 plus x to the 3 minus 6x squared. So I'm done with this one, so I go to the next one. So I have x to the 3, and this would be x squared and minus 6x. Okay. Then after that, I'm going to combine the like terms. Okay, so this one is x to the 4, so that's it. And the x3 term be plus 2x to the 3. And the square term, so this will give me minus 5x squared. And the leftover would be minus 6x. Okay, and that would be the equation.